Hey everybody, welcome to Video Notes 9.2. We're going to be able to define different kinds of solutions, talk about the rate of solution and solubility, and then interpret solubility curves, okay? Hopefully you'll be able to see clearly after these video notes, okay? So far, we asked the questions, will it dissolve? How does it dissolve? Now we're going to ask, can we make it dissolve faster? So say we had a solid chunk of sugar, a sugar cube. Can I make that dissolve faster in water? Okay, I bet you already have some ideas, but we can stir it, heat it, or grind it up. Okay, that's how we can make it dissolve faster. Stirring causes more collisions with the solvent, breaking it up, dissolving. Heating the solution causes more collisions with more energy, so that's going to speed up dissolving. Surface area, if we take that big chunk and grind it into a powder, same amount, but a powder, okay, then the water can attack every single surface of each tiny piece and it'll dissolve faster. So you can dissolve it faster or slower by doing the opposite of these. Now, what I want you to realize is making it dissolve faster does not mean you can make more dissolve. Okay, so the most that can dissolve is called the how much can dissolve question, and that is solubility. So solubility is a definite term now. Now we've been talking, is it soluble, is it not? But now we're going to define the word solubility. So here it is. The definition of solubility is the most solute, maximum solute, that can dissolve in a given amount of solvent at a given temperature. So the solubility is three things. It's the most solute in a certain amount of solvent at a given temperature. Why all three things? Because solubility depends on temperature, and we have to set the amount of solvent for our solute so that we can compare it to other things. All right. Now, I want you to realize that when we talk about solutes, we have different kinds of solutes. We have solids, liquids, or gas solutes. All right. So how much of a gas can dissolve is going to be very different than how much of a solid can dissolve. So let's look at the next slide. All right, let's go. All right. So temperature does affect how much. Temperature affects how fast and how much. It's the only factor that does both. Okay, so if you have a warmer solution, usually you can get more solid to dissolve. So higher the temp, more soluble for what? For solids. Okay, let's think about why. So you have a solid chunk of stuff, all right? If you have a higher temperature, you're going to get more water hitting it with more energy so that more can dissolve. All right. Gases is the opposite though. Remember, gases already have a very high potential energy. So if you increase the temperature, then you decrease how much gas is going to say in the liquid. Okay. So for gases, solubility goes down as you heat it up. Remember, gases are already like boom, 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 boom. I can go all over. Right? You put them in a liquid, they're dissolved in the liquid, but they still go all over. You heat up the liquid, like I am out of here. Okay, so temperature affects how much. Hotter solutions, more solid usually. Hotter solutions, less gas solute. Okay, pressure. How does pressure affect solubility? Well, it only really affects gases. Okay, so greater pressure, more pressure pushing down on a liquid. Then the gases will stay in there. Okay, we'll stay in here. We're gases and you're pushing on us. All right. Higher pressure means higher gas solubility. Okay. Higher pressure is not affect solid. Okay. Is not affect. That means does not affect. Okay. How about this? Does not affect. All right. Does not affect solid. All right. Less pressure. Well, less pressure means, see up there how I have three lines? Less pressure means maybe only one line pushing down. So this gas is like, hey, nothing's pushing down on us. We're out of here. So lower pressure means lower gas solubility. Right? But what does it do to solids? Nothing. Does not work on solids. Pressure. Okay, so temperature affects the solubility of solids by increasing it, gases by decreasing it. Pressure only affects gases. More pressure, more gas dissolved. Less pressure, less gas dissolved. Okay, so that's how much in solubility. But there's another way we could talk about solubility. You gotta be kidding. No. All right, so we're gonna talk about three kinds of solution saturation levels. Now, if you think of saturation, you might think of, well, I'm saturated with homework. I can't do any more. Well, first of all, I don't believe it, but maybe sometimes you are. So you can have a saturated solution, an unsaturated solution, or believe it or not, a supersaturated solution. So I have 3 buckets of KFC to help explain. All right, so saturated means full of solute. So our solubility is based on a saturated solution. Solubility is based on saturated. Solubility equals saturated solution, full of solute. Okay, unsaturated means unfull of solute. Oh, look, it's a bucket where you can still put more stuff, so it's unsaturated. Supersaturated is like, holy guacamole, look at that big old piece of chicken. That is unnatural. It should not be holding that much chicken in that bucket. Okay, so you might be saying to yourself, wait, saturated is full. How can you have supersaturated? I'm glad you asked. I'll explain it. It's not really a typical situation. So, hey, look, here's a line. What does that line represent? It represents the solubility of KNO3. So when we say solubility, we're talking about the maximum amount of solute. So guess what this line represents? A saturated solution. Anywhere on that line is a saturated solution. Okay, so let's talk about, oh, look, here's solutes. All right, grams of solute in solvent. Important to note that the solute and the solvent have to be included on the graph. But all of these amounts of solute were measured in 100 milliliters of water. Okay. Oh, look, it's the temperature. So as the temperature increases, the solubility of potassium nitrate increases. All right, so what's going to saturate 100 mils of water at 20 degrees? Well, boom, here, I'd say about, so for this one, about 38, okay, you know, a nice round number. Well, let's just go with 30 grams of KNO3 in 100 milliliters of H2O. All right. What about 60 degrees Celsius? 60 degrees Celsius. Well, here's 60 degrees Celsius. Boom, right there. So we're going to say about 110 grams of KNO3 is the solubility in every 100 milliliters of H2O. All right, what about at 85 degrees? Well, boom, let's go over here, 80, here's 90, so here's 85, which, boom. Let's say at 85 degrees, a saturated solution would be, I'd say 150 grams of, wait, I said 150 grams. I'm going to say 190 grams of KNO3 in 100 milliliters of water. So you have to decide what you're being asked, realize this line means saturated, and then at different temperatures, you're going to have different amounts of solute in 100 milliliters of water. Okay, so what is unsaturated? Unsaturated is below the line. If I added 150 grams of sugar, oh, look, it's sugar. 150 grams of sugar at 20 degrees, I'm right here. Okay, well, guess what? I could still add another 50 grams to saturate that solution. So if it's, your point is below the line of the saturation, then it's unsaturated. All right, what if I dump 250 grams? 250 grams of sugar at 40 degrees. Okay, so that's right here. Well, guess what? You can only dissolve this much sugar at 40 degrees. So this extra sugar will sit on the bottom, so it's going to be saturated with extra solid on the bottom. Extra solid in bottom of container. All right, now if you're at 20 degrees, oh, look right here. And you have 50 grams of sugar. Oh, look right here. But you want to make a saturated solution. Well, right now it's unsaturated, but I'm going to need 50, 100, 150 more grams. 150 grams more of sugar. Okay. So we got to be able to read these graphs. And we got to be able to take the numbers off the graph, whether it's temperature, whether it's amount of solute, whether it's amount of solvent, whether we need to set up a ratio, because this is for 100 milliliters of water, but what if we only had 50? Well, we can figure that out too. Okay, so we talked about supersaturated. How do I make a supersaturated solution of sodium chlorate at 40 degrees? Guess what? You can't. You cannot supersaturate a solution at a certain temperature. So if I go to 40 degrees, I go to here, this is it. That's how much solute can dissolve. That's it. Can't get any more at 40 degrees to dissolve. But what if I heated this solution up to 100 degrees? All right. So if I heated this up to 100 degrees and I added, 230 grams of sodium chlorate. right? It'll all dissolve, right? What if I cool that down slowly? Cool it. Temperature's going down, temperature's going down, temperature's going down, temperature's going down. And I get to 40 degrees, all right? So technically, this amount of solute should fall to the bottom of the container as it cools down because it's not allowed to be dissolved. But what if it stayed dissolved? Crazy, I know. But some solutes can actually, supersaturated solution, meaning all of this could still be dissolved. And if it's all dissolved, it's supersaturated. But wait, if you disturb it and all of this comes crashing out of solution, and you have this much extra solid in the bottom and only this much dissolved, then it becomes saturated again. Saturated. Okay, so here's how you make a supersaturated solution. You heat up water, you saturate it with your solute. It's got a bunch of solute in it. If you cool it down slowly, you expect the extra solute to come falling to the bottom because it shouldn't dissolve. Usually that does happen, but some solutes don't do that, and the cooler solution has too much solute, so it's supersaturated. Okay, we're going to try it in class. It's a fragile system, and the extra precipitate usually does fall out if you disturb the solution in any way. Okay, hey, it might even look like this. So what did this look like before? Well, it looked like the test tube, all right, like that, but it was all clear, all right? Now, if you're looking at a solution, you can't tell if it's saturated, unsaturated, or supersaturated. So you got to do a test. Let's do the test, okay? How to test for the type of solution. Okay, so you have this container, and look, you can't tell what it is, saturated, unsaturated, or supersaturated. So we had one more crystal, okay? So I had one more crystal. If this goes in and falls to the bottom, then your solution was saturated. In saturated solution, a crystal will fall to the bottom. Okay, it won't dissolve. Won't dissolve. All right. But what if this was unsaturated? Okay, here's your solution. If it's unsaturated, put this crystal in, and then it goes in, and then you don't see it anymore. It will dissolve if it was unsaturated. Okay. All right. If you added one crystal to a supersaturated solution, then you would start to see a bunch of crystals form. The crystal will cause all extra crystals to precipitate or become solid. Precipitate. Oh my gosh, can you spell? Okay. So what kind of solution do you have after the test? Well, after the saturated solution test, if you see it fall to the bottom, then you know it's still saturated with stuff on the bottom. After the supersaturated test, you know it's saturated because all the stuff that couldn't dissolve falls out and it becomes saturated. The only one you're not sure of, if it's unsaturated, the crystal dissolves, but you have to keep testing to see if it was saturated or unsaturated after. Back to the graphs. Okay. All right. What temperature has 80 grams of KNO3 dissolved? Okay, so we're at KNO3, 80 grams. Boom. Down. What do you think? You think 40? Okay, so here's 50, 43 degrees Celsius. Okay. What mass of KBr makes a saturated solution at 70 degrees? Well, here's 70 degrees. Here's KBr. I'd say we're at about 90 grams of KBr for every 100. Oh, look at this time. It's grams of water, grams of H2O. Hey, this is the solubility because it's a saturated solution. All right, we did that. All right, so here we go. We're going to review, and hopefully you'll see clearly what's going on. How fast it dissolves doesn't tell you how much, but just how fast. How fast is what you can do to speed it up or slow it down. How much, you got to check the solubility curve. Right? Supersaturation is an overachiever. Solubility curves show where it maxes out. And then mixtures can be separated because of... Hey, we did that last time. Come on. All right, you already knew that. So anyway, I think we can make it now that the pain is gone. All right, we can define this stuff. We can talk about temperature, surface area, stirring, etc. We can interpret and calculate solubility curves. We are set. So peace out.